I don't know if you can hear my fan. It is loud. It is angry. That probably means we're getting close to wrapping up for this lesson, lesson 2. So let's get into it. So we kind of discovered, I kind of quick and dirtily introduced comparison operators, right? And we kind of have this machine where we're like, okay, it's going to move to the right, and then the ball's going to move to the left, okay? And so there's a few things here, right? So the first question is, what are we varying, okay? And the second question is, how do we get this condition? How do we actually program this, okay? And what are some of the details we have to figure out? Well, in the last question, I had you check your knowledge, and what we were varying ended up being center X, right? If we're going left and right, it's center X, okay? And there's something else. There's something that's also being varied, and that's the direction, okay? And we'll change that variable in a second. So don't get excited about that variable. I don't know if anyone's actually excited about that variable. We're gonna change the name in a second here. Okay, so we have int direction, all right, and then in setup we're gonna give these things all initial values, and I think that's a good way to remember to set these things, right? You can initialize them up there, set them in setup, all right, because then we won't try to use width and height before size, and that's actually what setup's for. It's for giving things initial values. So let's use it the right way. Okay, so our direction is going to be positive, so we'll just say it's in the +1 direction right now, okay? And now we have void draw, and void draw has center X and center Y, and then we could say something like, well, center X, all right, equals center X plus direction, right? Okay. And maybe we would call it direction X. Calling it direction is a good way to get us in trouble, okay? Direction X. Direction X, okay? So the direction in the X coordinate, okay? And so when it starts, we would hope this thing goes to the right, and let's put a background in there so we don't see 9 million circles appear. And I'll make it 230 or something like that. It'll be a little more like a sheet of paper. Well, trust me, it worked. Okay, it's going to the right, except it didn't stop and flip, right? So we need to have a way to say, well, when this thing gets to that point, we go in the negative direction, right? So we have to say if, and remember, if is how we figure out how we ask this question, this true or false question. So we start with if, and we have this mathematical expression here where we said center X, right, plus, and we can just say ellipse width over 2, okay, center X, ellipse width over 2, and some of us were like, okay, equals equals, right? I said we can't do this, but let's find out why. Equals equals width, okay? If that's the case, then ellipse width. Oh, we never had a thing for ellipse width. So right now the ellipse width is 50. Sorry about that. Okay. We could just put an ellipse width here. Why not, right? Let's live a little. Let's live a little. Okay. Ellipse width equals 50. And actually this is good because it'll motivate us doing objects, which we will also do pretty soon. We will probably start next time. I wanted to start it this time, but not with that fan, which is actually kind of going down a little bit. Okay, ellipse width, what did I not like about that? It's never been declared. So let's declare it up here. Int ellipse width. Okay, so it's declared, it's initialized, and we put it in there. Now, ellipse width is not varying, but I just did it so that it matches the equation up here. We could also have ellipse height here. And we could vary ellipse width, right? If you wanted to see the thing grow bigger, that might be something you would vary. Why not? We could do that as well. Okay, well, whatever. I'm giving you like 9 million assignments this time, but that's fun, right? It's processing. Finally, we're doing something fun. Okay, so center plus ellipse width over 2, right? We'll just do this. So we can change the ellipse width whenever we want. Over 2 equals width. And then we have to go the opposite direction. So when direction's positive and we're adding direction to it, it's going to go to the right. And then if we want it to go to the left, we just need to flip it and have it go the opposite direction. Some of you might have thought about this already. Maybe I'll put a question on it before this video. But we could say something like, if we times it by -1, which you could do this way, you could say 1 times, and I named it direction x. You could also say 1 times, -1 times that, if that looks better to you. All right. Yeah, let's do that actually. Let's make it like real clear what's going on here. All right. So the new value of direction is going to be the old value of direction times -1. Okay. And so the old value of direction was 1 to start out with. Then it's going to be -1, and it's going to go the other direction. Okay. So now if I hit play, this thing's going to go, and okay, it bounced. That's pretty good, right? Now, obviously, we need to do something else on this side. That'll be an exercise for the reader. Okay. But yeah, it bounced. So then why, Ashok, why are you making such a big deal about this, right? Why are you saying, Captain Bring Down over here, right, saying we can't use equals, we used equals, and it looks great, okay? So in physics, right, and I know people glaze over when they see physics, but this is actually really easy. In physics, what we actually are calling direction is something we would call velocity. Velocity has a heading and a speed, okay? So I'm going 50 miles per hour is the speed, but I'm going 50 miles per hour in the north direction. That's a velocity, okay? So the direction part plus the speed tells you velocity, okay? So right now we have a direction, the speed's always 1, right? But we might want a faster ball, right? So what if we come over here and instead of calling it direction, I told you not to get too attached to that name, right? I warned you. Y'all having pictures of direction up in your plate. This is such a bad bit. I don't know why I'm doing it. Okay. Velocity x, all right? And we haven't changed anything. We just changed direction to velocity. Well, almost. Velocity, okay? And velocity, all right? Flipping of the velocity means you're going the opposite direction. It's equivalent to that, okay? And we're doing this, and cool, all right? And now, let's say I want to make it go a little faster, right? So I say velocity, velocity, instead of the velocity being 1, we make the velocity 3, right? That means it's going to jump 3 each time, okay? So it'll go a little faster, which means I have to really move this thing fast when it comes up here. And it's going, and it bounces off. So Ashok's being a little crazy, right? This is not a big deal. Well, at some point, we're going to move this velocity, right? And when we move this velocity too much, this thing will fly off the edge. Trust me, it flew off the edge, okay? Well, why does it fly off the edge? It's actually pretty logical, okay? If we're using equals, right? How are we doing this? Put the Zoom meeting in front. Oh my God. If we're using equals, what's going on here? Well, the ball is jumping 10 pixels each time, okay? and it might never equal the end here. In fact, we were lucky it equaled the end at the 3 times, right? Because this might never be true. It might never have this situation, because it might just skip right over it. Now, in our minds, we integrate it all together and it looks smooth, but that might not be the case. So, what is going on here? What do we have to do? Well, instead of saying strictly equals, what we want to say is when this is greater, so when the center x plus width over 2 is greater than the width of this thing, right? Because if that's the case, you still want to flip, all right? And so let's do that real quickly. It's not too bad. So we're going to come up here and we're going to go, instead of this, we're just going to change it to that, okay? And I'll slow it down because I couldn't get it in time. We'll do it at 5 or something like that. Okay, it'll still be fast, but I can. Okay, it bounced, all right? We're all happy it bounced. All right, so that's the idea. I have